800 by 480 pixels in resolution. So there's 8 configurable warning lights, so RGB LEDs here that you can configure the frequency of flashing as well as the color, and then 10 configurable lights here for shifting, so you can see them illuminated here in all their different colors. So this particular device has Ecu connectivity in the form of CAN, RS-232 or K-line, and RS-232 as well as CAN is available with the 14-pin standard harness that comes with the unit itself, and this can communicate via OBD2 or CAN communication with a number of different ECUs that AiM supports. With the auxiliary 23-pin harness, it adds a second CAN input as well as another pulse or RPM input and a low side digital output, as well as 8 analog channels that you can wire into the device. So I'll show some examples of how that is useful for things such as turn signals and warning lights and headlights and things like that, where you can use this as a dash replacement for a road-going streetcar, or some more advanced features for a circuit or track car. So currently we're connected to Race Studio 3, and this particular device has been configured for a C7 Corvette ECU protocol, so all of those parameters are available. Since we're not currently connected to a vehicle, we're simulating these parameters. So you can see in the top right corner there the oil pressure here of 19 psi, and because that's below some alarm threshold, you can see this warning light here, warning for oil pressure. So if we force the channel for oil pressure to say be 25, which is above the allowable threshold, you can see that icon go away and the warning light go away there. We have an engine oil temp and an engine coolant temperature here. So an engine oil temperature of 255 degrees Fahrenheit, which is hot enough to illuminate the icon here and send the user a warning. So we will change that to something within an allowable range here, and you can see that goes away there. For the coolant temp being overheated, we can also change that to something more reasonable and see that go away. We can also, if the engine is currently warming up, let's say it's only 100 degrees Fahrenheit, we can have another warning light that shows that the engine temperature is cold. Currently we only have the battery is not charging, so this is showing that the battery is discharging. If the voltage is below whatever the nominal charging voltage is, we've configured this light to illuminate below 12.7 volts when the alternator begins to charge when the engine is running. That will go away, as well as the fuel level. So currently anything below 10 liters of remaining fuel, we're illuminating this red fuel warning light, and then, or I guess this is a low fuel level warning light, and then this is just a moderate low fuel level warning. So if we go to, let's say 15 liters here, the red will go away and it's just a warning and not a fuel level low. And then if we go above 20 liters, so we'll make it 22, that goes away. This eco light will illuminate whenever the throttle position is below a certain percentage, 20%. So if we change the throttle position to, let's say 25, you can see that goes away. Okay. The final thing that we can do here is, you can see obviously a tachometer reading. We're simulating 4,950 RPM, and it's calculating we're in 6th gear. We can simulate the vehicle speed here to, let's say, be 119 kilometers per hour. We can also, which is very useful for streetcar applications, we can turn the headlights on, or at least simulate turning the headlights on here. So that's simulating one of the analog channel inputs that can be wired in from the headlight switch on the vehicle. That's showing that the headlights are illuminated. And then, let's say left and right turn signal flashers, we can force the value here for the left turn signal to show up. And then we can do a similar thing for the right turn signal here. Okay, and we'll turn that off, and we will turn the headlights off, and we can go to the next page here. This is kind of an ECU check page showing all the available parameters that this particular ECU protocol has. So ECU, so the engine RPM, the oil pressure switch, and that's basically a digital signal that says if the oil pressure is below a certain threshold, it's going to turn that switch on. We have brake pressure. This particular vehicle is equipped with a brake pressure sensor, the transmission speed sensor, or the vehicle speed sensor in the transmission, the brake pressure switch, so when the brake is depressed above a certain pressure threshold, it's going to signal this particular digital value. The ECU, engine coolant temperature from the ECU. This is the transmission temperature that we're simulating currently, the engine oil temperature, the throttle position, the clutch switch, the intake air temperature in degrees Fahrenheit, the oil pressure that we're currently simulating. This will be your lap number, your lap time. Currently that's our battery voltage, hence why the battery light was illuminated on the dash. This is your front left wheel speed sensor, and all four would be available when connected to the vehicle. This is your malfunction indicator light from the ECU, so if there's a check engine light, it will illuminate, or I guess populate this with a non-zero value. And then this is another ECU parameter that's shown here. So this is one way to visualize the data with a large, this is kind of a rally style page with a large gear indicator here. We can go to this, which is more simulating a stock appearing streetcar dash, so you can see a tachometer between 0 and 8,000 RPM. So we'll simulate what happens here when we start approaching the rev limiter. We'll go to 6,500 RPM, and you can see some of the lights at the top here are illuminated. We can go, let's say, to 8,200 RPM, and it will warn us that we've exceeded the rev limiter here. So we'll go back to 4,950. So we have a conventional tachometer here. We have a speedometer that can be user configurable to a variety of different maximum speeds, gear position, and then an odometer for the entire unit, and then a trip meter effectively, and then the pertinent ECU parameters like the intake air temperature, throttle position, engine coolant temperature, and then the battery voltage in this page. So this simulates somewhat of a stock appearing streetcar dash. This is a similar visualization of the same data. However, this page is obviously has a different graphical interface for a more modern appearing streetcar dash. So these pages are user configurable in Race Studio 3, and you can select between a variety of different page layouts that have been pre-configured. So this is showing similar information to what was shown in the previous page. And then when we come back here to this icon page, let's say, that will show all of the icons at the bottom when there's a warning that's pertinent to the user. You can define the thresholds and the conditions to when these icons will illuminate, and you can also define your own custom icons if you'd like. That's available in the Race Studio 3 software. So if we go to, we'll remove the speed here. And the RPM, and we will go to see what happens when we want to look at the memory that's saved in the device, so any of the sessions that are available. So currently this was the past session, and it's 11 minutes and 24 seconds that we were simulating an RPM input, which triggered the logging session. This is the maximum RPM that we simulated, and that's the maximum speed. If we go back to tests, you can see a few different tests here from this particular day. So if we click enter, we can obviously see different values here and different lap times. So this allows you to kind of see maximum and minimum RPMs and speeds, as well as lap times on the device directly without using Race Studio 3 software. So if we click back, we can see different dates that have been categorized with the logging sessions for that particular day. So we can go to another day here and see all the logging sessions that were triggered there. This device can also be configured, or optionally included is a GPS 08 module. So instead of using the ECU signal for vehicle speed, you can also include a GPS 08 module, which will allow you to do track mapping and GPS-based lap timing on the device if it's more of a track application for this particular device. There's no logging enabled on this device because it is the Strada model. However, that does offer some cost benefit to the device for this particular price point. If we click menu, there's a few options that we can configure. One of the nice things with the MXG 1.2 is that if we go here, there is 2 video inputs that you can actually select on the device. So once we click that, you can see here, there's no camera actually plugged in, but there is 2 camera inputs that you can use this as a rear view or mirror camera, or even a forward-facing camera in a race vehicle application. But obviously in a street car application, a rear view facing camera might be pertinent, so the user can actually access this via the buttons here, and they can also have a remote button that can trigger this this rear view camera. So if we go here, it'll show the counters page and how many kilometers the device has underwent, and then a few user configurable trip meters, and as well as an hour meter. This allows you to access all the GPS tracks in the database here, and then this system info will show you the logger name, the serial number, firmware version, and the boot version for the particular device. And that is a features and overview summary of an MXG 1.2 Strada.